In this video 6.2, we are going to be solving systems using substitution. So we've gone over how we solve by graphing. Now we're going to look at the method with substitution. So by the end of the video and work time in class, you should be able to say, I can solve systems using substitution. We're going to look here at y equals 5x and x plus y equals 12. This is a system because we have two linear functions or linear equations. With substitution, it's always nice when you have one variable or one of the equations already solved for a variable. So in this case, I know that y is 5x. So what I'm going to do is I'm going to take x plus y equals 12, which is the second linear equation here, and I'm going to take out y. Now, I know what y is in terms of x. Y is 5x because it says so right here. So I took the second equation and I replaced the y with what I said the y equals in the other equation. So now I just have x plus 5x is 6x, which is 12, so x is 2. And if x is 2, I can find y. I take y, which is 5 times x, and I replace what I'm saying x is, which is 2, and I'm now knowing that y is 10. So the solution is the ordered pair 2, 10. And if I were to graph both these equations, I would see that they intersect. They're consistent at that point 2, 10. This is yet another method to solve a system. What is the solution of the system using substitution? So now we look here, we've got 7x minus 3y is 2, and then we have negative 2y plus x is negative 6. See, in the first problem, it was really nice because when we look back at that first equation, the y was all alone. And that's really what you want. You want one of your equations to have one of the letters all alone. So in this case, we have to get one of the y's alone. Let's take the bottom equation and let's solve that bottom equation for y. So I'm going to take negative 2y, subtract x from both sides. I'm left with the opposite x minus 6. Now I have to divide both sides by negative 2. So I'm left with y equals 1/2 x plus 3. So now we have y all alone in this second linear equation in the problem. Now we're going to take the other equation, which says 7 times x minus 3y. Well, let's come down here. What do we know that y equals? Y equals 1/2 x plus 3. So it's 3 times y, so I'm going to use a parenthesis here. It's going to be 3 times y, which I know is 1/2 x plus 3. So I removed the y right here, replaced it with 1/2 x plus 3, and that equals 2. We can see over here on the left side of the screen. So now I'm going to simplify. I'm going to distribute, so I have 7x minus 3/2 x minus 9, which is the same as 2. 7 minus 3/2 gives us 11/2 x minus 9, which is 2. And then I'm going to add 9 to both sides. So I have 11/2 x is the same as 11. To get rid of 11/2, I'm going to multiply both sides by the reciprocal. So my x, this simplifies, is 2. So if x is 2, now we have to find the y. So now what we're going to do is we're going to come right here. We're going to find this y. We're going to take y equals 1/2 times x, which we just solved for, is 2, plus 3. Half of 2 is 1. So 1 plus 3 gives us 4. And so we're left with the ordered pair for our answer. The ordered pair would be 2, 4. And that is where those two linear equations will cross on a graph. The school bookstore sells t-shirts for $8 and sweatshirts for $12. Last month, the bookstore sold a total of 37 t-shirts and sweatshirts for a total of a profit of $376. How many t-shirts were sold? We can take this information and come up with two linear equations. One thing we know is that if we have t-shirts, X, plus sweatshirts, Y, they sold a total of 37. So we know X plus Y is 37. We also know the cost per t-shirt was 8. So 8 per t-shirt plus that 12 per sweatshirt, 12 per sweatshirt gave them a total of $376 that they made. So there is our two equations. Now the nice thing you want to do here is, or what you want to do when you have, when you're using substitution, is you want to look at which equation is it going to be. Really easy to get a variable alone. I think this one right here. I'm going to get the y alone. So y equals the opposite of x plus 37. And so I'm going to come down to the second equation, and I'm going to replace y with this. Put it in parentheses because you multiply the 12 by everything that y is. And that equals 376. So we just replaced the y with what we had solved it for in the first equation. Now we distribute and we simplify, and then we're going to solve. Oh, I'm going to erase that here because I know that I'm going to end up with negative 12x, and then plus, because 12 times 37, plus, that would be 444, and that's 376. And then we're left with 8x minus 12x, that gives you negative 4x. And if we subtract a 444 from each side, we're left with negative 68. Divide both sides by negative 4. And we're left with a positive 17. And so now we know what x is, so now we're going to find y. We're going to come up here. Y is the opposite of what the x is, which is 17, so negative 17 plus 37. So that gives us y is 20. And so for our solution, we would be at 17, 20. But now, let's see, it said how many t-shirts were sold. So for t-shirts, that would be 17 t-shirts. How many solutions does each system have? So we're looking here at x is the same as negative 3, y plus 4. And so x is all alone, which is really, really nice. X is alone, so I know what x equals in terms of y. And then I have 6y plus 2x equals 8. So I'm going to take the second equation, which is 6y plus 2x. Now this x right here, we won't know what x is in terms of y. So I'm going to take out that x, replace it with negative 3y plus 4 from the top equation. So we just substituted that x for what x equals in terms of y. Now we're going to simplify the left side. Use your distribution property. What happens here is 6y minus 6y is 0, so you're left with 8 is the same as 8, and no matter what you put in for y, you would always get 8 equals 8. If you ever end up with some number equaling that number, which we know is true, no matter what you put in for y, no matter what you put in for x, it's always going to work. That means this would be a problem where if we were to graph the lines, they're the same line. They're the exact same line. So this is where we would have infinitely many solutions. They have everything in common. In the second problem here, we see that y equals 4x minus 9. And so it's nice because y is all alone right here. And so if that's the case, I'm going to take my other equation. And so if I'm saying y is 4x minus 9, I'm going to replace that y in my second equation. Right here, I'm going to take that y out. So 4x minus 9 is what I'm saying my y is, minus 4x. That equals 6. Well, right here, 4x minus 4x is 0. I'm left with negative 9 equals 6, which we know isn't true. So this is a kind of problem where no matter what you put in for x or y, it will never be true. This is one of those where they're not the same line. They don't have anything in common. They will never cross. So this is no solution. Can you say I can solve systems using substitution? Write a summary and reflection and be prepared for the work time in class.